if you dissolve 75 grams of aluminum nitrate in 750 grams of water, what is the molality? So again, still trying to find molality, but we got to do more converting. So let's do, this is my solvent. So it's in grams, so I got to convert it to kilograms. So 1, 2, 3 to the left, King Henry. So my kilograms, my solvent is going to be 0.7500 kilograms. I got to get moles. But I have to convert this from grams to moles first. So again, you're just dividing your grams by your molar mass. So 26.98 for aluminum plus 3 times N, 14.01, plus, looks like 9 times 16, 213.01. So 75 divided by that number gives me my moles, which is approximately 0.35209614. Going to put this back up here. So 0.35209 ... Divide the two of them. Divide the two, and I'm going to end up with .46946 ... I have the smallest number is going to be 3 sig figs, so my answer is going to be, let's see, 1, 2, 3. That 0 doesn't count, so 0.469, then lowercase m, then ALNO33 boxed in. How much water should be added to 6.50 grams of KCl to prepare a 0.500 molal solution? So how much water? This is my kilograms of solvent right here. This is my molality. This is my solute right here. So I need to do it this way. So molality equals kilograms and then moles. I want to solve for kilograms. That's what I'm trying to find right now. So this one right here, this one's going to be kilograms equals moles on top, moles on top, and then molality on bottom. So now I got to plug in, I can plug in my molality, so that's good. However, I need to convert my grams of KCl to my moles. So 6.50 grams KCl, convert that to moles. So I'm going to divide by the molar mass, which is 39.1 plus 35.45, and that's about 74.55. So this is my moles. Small numbers, 0.087189 ... So I'm going to plug this in up here. Divide the two numbers. I end up with, for my kilograms, 0.174379 ... I have 3 sig figs, so my answer is going to be 0.174, then kilograms of water. Alrighty, so next topic is common non-electrolytes and electrolytes. So this is important because it's going to help you with these colligative properties. So non-electrolytes and electrolytes. So non-electrolytes what they do, they're considered molecular. You notice that, again, it's like a lot of the oses, so sugars and alcohols. Okay, a lot of carbon, hydrogen, nitrogen, etc., and oxygen as well. I'll talk about what these things don't do, or what they do in a little bit. And then electrolytes, right here. Remember, electrolytes means they conduct electricity, like I showed you in that video before. So when they're put into solution, when they're put in water, something happens. So you'll notice that they're splitting up. Okay, so keep that in your mind. Okay, keep focused on that. So what happens when a non-electrolytes and electrolytes are put in solution? Non-electrolytes, like the sugars and alcohols, etc., they exist as neutral molecules. A 1 molar solution of glucose is still a 1 molar solution. That's important. It relates to something we're going to talk about in a minute. Electrolytes, however, they exist in solution as separated ions, so they separate out. If you have a 1 molar solution of NaCl, when it's put in water, it separates out. So technically you have 2.0 molar solution, because you have a 1 molar of the sodium ions and 1 molar of the chloride ions. So this relates to something we're going to talk about in a few seconds, and this is the Hoff factor. So Hoff factor, it is the ratio between concentration of particles produced when a substance is dissolved. So that's a lot of words. Here's a way to remember it, or the best way to think about it. If it is non-electrolyte, the Hoff factor is going to be 1. If it's ionic, it depends. It depends on how many things there are. So you'll see that if something is molecular, it's a Hoff factor of 1. If it's ionic, it depends. So sodium chloride breaks up into 2 things, so then the Hoff factor is 2. If something is going to break up into 3 things, because you have a Ca2+, then you have a Cl- and a Cl-, so it's 1, 2, 3, so your Hoff factor is 3. Okay? So that is it for now. That's the conclusion of this lecture for today. If you have any questions, please do not hesitate to contact me.